This is Unit 7 Circles, Lesson 7.4, Inscribed Angles. Find this portion in your video notes. You should note the date and location that you are working on these, as well as don't forget a parent, guardian, or teacher sign-off. Let's do a recap of a similar problem that we just had. Last class, we just talked about circumference and area. So let's do a problem together. First off, we're going to finger track read, and then, so here, oil barrel has a diameter of 34 inches. The ramp of the loading dock is 20 feet long. How many revolutions will it take to go up the ramp? Step one, we're going to highlight or underline. We have a barrel, which is a diameter of 34 inches. We have a ramp that's 20 feet long. How many revolutions will it take? So we have highlighted and we have underlined. Step two, we're going to draw a label list and cross out all at the same time. We have an oil barrel here, and the diameter is 34 inches. So here we are right there. There's our oil barrel, and our diameter is going to be 34 inches. We're going to cross stuff out as we account for it. The ramp, so we have a ramp up to a loading dock. So here's our ramp, here's our loading dock. And that ramp is going to be 20 feet long. How many revolutions? Revolutions is like this, trace. Revolutions is around. Will it take to roll that barrel up the ramp? So if you turn the barrel on the side here, okay, imagine there's barrel. Some of you do a better job at 3D than I do. So here's your barrel. And we want to roll it up the ramp. So we're going to be rolling, and the question is, how many rolls does it take to get up the ramp? Let's bring that 34 right here. Diameter equals 34 inches. Okay? So how many rolls or revolutions will it take? Okay, we draw a label list, we cross stuff out. Okay, the first thing you need to get in your head is that when we talk about revolutions, so revolutions around this way, revolutions that way, revolutions is code for circumference. Revolution and circumference means to go around the circle. So when we do squeeze the sponge, we ask ourselves what we can do. The first thing you know you can do is you can write out the equation, which is C d pi, I d pi. So it's circumference equals d pi. So let's go ahead and figure that out, what we have so far. Circumference equals, we circle the D, we pick up the D, which is 34 inches, and here we have pi. Now because we have to do something with it, we need to get that in decimal version, so we're going to do 34 times pi. So 34 times the pi key, and we get 106.8. 106.8, and we're dealing with inches here. So every time that barrel rolls, it's going to travel 106.8 inches. Now, when you ask yourself what else you can do, you should always make note of your units. We have feet here and inches here. And you need to remember this, convert before you crunch. Convert before you crunch. So before we can mess with these two numbers, we need to get them all in the same units. We're going to take the feet and put it into inches, so 20 times 12. That's going to be 20 times 10, which is 200, plus 20 times 2, which is 40. So I have 240 inches. So for this barrel to go up here, it's going to have to travel 240 inches. Every revolution gets me 106.8 inches. So I'm going to go 240 inches divided by 106.8 inches. You can see revolutions, it takes approximately 2.2 revolutions to get up the ramp. 2.2. So this barrel with these dimensions has to go around once, go around twice, and then a little bit more to roll up that ramp. 2.2 revolutions. All right, let's get into today's lesson. In today's lesson, here are your vocabulary words. Of course, we're talking about circles, chords again. The word inscribe is new, circumscribe is new, and then an inscribed angle is new, and then that word frame is new. A very important piece of equipment. Either you pick this up in class or it's already in your video notes. You absolutely must have a set of Post-it notes with you. If you don't have a set of Post-it notes, you can get 2 3x5 cards out. Okay, you need 2 3x5 cards, or you need 2 Post-it notes. Absolutely critical that you have that handy. You're going to need it. You're going to see why in just a moment. All right, first we're going to go over a couple vocabulary words. I'd like you to underline these vocabulary words. One is circumscribe, and the other is to inscribe. Circumscribe. Scribe means to draw or write, and this prefix, circum, means to go around. So we're going to circumscribe a square around the circle. When you circumscribe something, you're going to draw around, and the sides are going to touch. So I'm going to use red for this. We're going to circumscribe a square around the circle. The sides must touch. So here's your square. Okay, so the square is circumscribed around the circle. That means to draw around. Okay. Fill out those blanks. Inscribe. In, of course, means in. Scribe means draw. So we're going to draw inside a triangle inside the circle. And when you inscribe something, it has 2 qualities. The corners must be touching the inside of the circle, or the vertex is on, and the arms are in. Arms. A-R-M-S. I had that backwards. The arms are in, so we're going to inscribe a triangle. So let me tell you what it's not. Don't draw this right now. Just watch. That purple triangle is not inscribed. It's simply drawn inside. Inscribe means specifically the corners must touch. The corners must touch the inside of the circle, and then the portions of the triangle are inside. So inscribe means to take it right to the edge, but still inside. That triangle is inscribed. That is an inscribed triangle. So inscribed specifically means the vertex is on. Vertex is on, and then when you have angles, the arms are in the circle. Okay. Now we're going to come back to that word inscribe. Put a little star by that word inscribe. We're going to be coming back to that. Now we're going to talk about a central angle versus an inscribed angle. There's a difference here. A central angle versus an inscribed angle. Let me get this real close for you. I'd like you to trace angle ACB. Trace with me. A, C, B. A, go to C, go to B, and sweep. That blue angle is a central angle. Why is it a central angle? Because its vertex, that's the vertex, is on the circle's center. That's why it's called a central angle. So you were introduced to this as the pie slice angle. That's a central angle. And we learned previously that measure of a central angle to its arc the same. So if that's 102, this arc, the measure of arc AB, is also 102 degrees. Because measure of a central angle to its arc the same. That's your first angle of circles. Let's try the second angle. Now we're going to draw in angle ADB. ADB. Be real careful with this. So here's your central angle. I'm going to do that again in blue. That's your central. I'd like you to trace and draw that again. I'm going to pause and wait for you to do that. Okay, now we're going to draw in ADB. ADB. Notice I changed. It's not ACB, it's ADB. So start at A, circle D, circle B. This is where you need your straight edge, please. Okay, the angle ADB, after you trace it, after you draw it, I'd like you to trace it. Now trace again with me. ADB. ADB. Now notice that D is not on the circle's center. It's on the circle's edge. D is on the circle itself. That's why we call this an inscribed angle back here. Definition of an inscribed angle. An inscribed angle, it has the vertex on the circle. The vertex is on the circle, not on the center. And the arms of the angle are in. They're in the circle. Vertex on, arms in. Vertex on, arms in. That is an inscribed angle. Get your Post-its, please. Okay, now I'm going to be using the term frame here. Frame. It's very important that you don't just copy this video. It's very important you actually use the Post-its. That's why I provided them for you. Use the Post-it notes, please. When I ask you to frame, this is what I'd like you to do, please. Take one of your Post-its. Follow with me. I'm going to slow down real slow here. Take one of your Post-its with the sticky side, and I'd like you to run it along A to D. Put one of the Post-its, going to be like this, with the sticky side there. Okay, there's your Post-it, like so. I'd like you to tack it down on your paper, please. So put the sticky side. This is going to be the sticky side right there. Tack it along the sticky edge. Okay, so you put your sticky edge of your Post-it note there, so that you're right at that vertex D, and you go to A. Now, grab the other Post-it, put it right along the other arm of it, D to B. So here's another Post-it. It's going to go off your paper probably. Okay? I'd like you to put your Post-it on your paper. Again, the sticky edge right there. Please actually do this. Don't just stare at the video. Get the Post-its out and frame that angle, please. When I say frame, this is what I want you to do with the Post-its. There's a very, very important property here. The central angle is the same as the arc. So that central is 102. That you bring your 102 here. This inscribed angle is obviously smaller than the central. There's a really simple concept. Trace that. Now sweep it. The central angle is the same as the arc. The inscribed angle is half the arc it's grabbing. So this angle back here, right back here, this inscribed angle, way back here, that's not 102. It's going to be half of that 102. It's going to be 51 degrees. So what we know here is I'd like you to just write this down. Right, central angle equals the arc. That's something you learned earlier. The central angle equals the arc. An inscribed angle is half the arc it grabs. Half. This is really easy to work with if you use the Post-its. Let me give you a couple examples. We're going to do several problems together. Okay, it says right here, properties of an inscribed angle. If you have an inscribed angle, then it measures half the arc it grabs. Okay, let me show you what I mean here. Step number one. We have an arc here. I'd like you to just physically trace this arc. I'm going to use orange here. Trace that arc, 76. Okay, now get your Post-its, please. Now I'd like you to trace, please, the angle ADB. ADB. Notice the arms are in and the vertex is on the circle. On the circle. That means that angle ADB is inscribed. And we learned that the inscribed angle equals half the arc it grabs. Get your Post-it notes, please. I'd like you to put one Post-it note along AD. Put a Post-it note here. Ready? And I'd like you to put a Post-it note here. Now we have framed that angle. The inscribed angle is half the arc. So trace with me. If this is 76, This back here is half the arc. So we do here, the arc is 76, the angle is half of it. So the angle equals 76 divided by 2. 2 goes in there 3 times, 1 left over, 38. So this angle back here is 38 degrees. Okay, pull your Post-its off. Now let's see what else we can find here. You have another inscribed angle going this way. I'd like you to trace this inscribed angle. DBC is inscribed. B is on the circle. And BD is in, and BC is in. That means it's inscribed. And write this out in the margin. Inscribed angle equals half the arc. Get your Post-its. Lay one Post-it here. And lay one Post-it here, please. So here what we have, the inscribed angle is half the arc. We have the angle is 45. So we ask ourselves this: what divided by 2 gave us 45? That's what you're thinking. What divided by 2, half of what is 45? You should be able to see that this arc here is therefore going to be 90 degrees, because 90 divided by 2 is 45 degrees. So the measure of arc DC is going to be 90 degrees, and that's what we wanted to begin with. Let's try another one. So first off, let's fill these out. We're going to do this in 2 different colors. We're going to find measure of ADB, and we're going to find the measure of ACB. So let's trace those very carefully. Okay, ready? Start at A, go to D, go to B, trace and sweep. That's inscribed because the vertex is on the circle and the arms are in. And now let's do ACB. Start at A, go to C, go to B. That's inscribed as well because the vertex is on the circle. Now we want to find those measures. Now they're both inscribed because the arms are in, the vertex is on. So what I'd like you to do is get your Post-its, please. Ready? I'd like you to lay one set of Post-its. Let's go along the blue first. So put your Post-its here. Frame this. And put your Post-it here. Frame that. We know an inscribed angle is half the arc. So if this out here is 124, back this way is half. That's why we frame it. It helps your eyeball see. So of course that's going to be 62 degrees. Because the inscribed angle is half the arc. Now we're going to move your Post-its. Now let's frame the red angle. Move your post-it one here. And move your other post-it here. Frame that angle up. Again, we know this inscribed angle is half the arc it grabs. So if this is 124 way back here, this also must be 62. So take a look. The red and the blue angle, the measure of this was 62 degrees. The measure of the red was also 62 degrees. Notice the blue and the red grab the same arc. If they grab the same arc, they must be congruent. So if inscribed angles grab the same arc, it's automatically congruent. Okay, that's one property. So if two angles inscribed grab the same arc, they're congruent. Let's try another one. We're going to draw an angle EHG. Let's do that now. EHG. So here's E, here's H, here's G. Get your straight edge out and draw an angle. E to H, H to G. Trace and sweep. We're drawing it inside a semicircle or half a circle. So there's your half a circle. Here was E, here was H, here was G. We know it's inscribed because H is on the circle and the arms are in. This is a very important property here. I'd like you to get your post-it notes and frame, please, this angle. So frame here, one post-it note over here, and then put another one on this side. Frame it up. This inscribed angle is half the arc it's grabbing, so I'd like you to sweep that. Now I'd like you to sweep the arc it's grabbing from this end of the post-it, physically sweep, follow, 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 keep going, right to there. Notice that blue, the arc it's grabbing is 180 degrees. That means this angle back here is half. It's going to be 90 degrees. So this leads us to a very simplistic concept. When we inscribe an angle inside a semicircle, you're always going to have a right angle. Okay, when you inscribe an angle, if an angle is inscribed in a half circle, then it is a right angle. Okay, we're going to do just two more problems together here. Have your post-its handy. Follow with me, please. It says, trace the arc M to L. Okay, notice that's two letters, so we go the short way around. So trace M to L. Now also trace M to K. M to K. Then it says, trace the complete circle. So starting at L, sweep around. I'd like you to trace the complete circle. We want to find all arc measures. So we're going to do that first. Find all arc measures. Arc measures. So let's see what we can do here. If the whole thing adds up to 180, We already have two pieces here. Here's 55. Here's 115. To find this, not 180, 360. We're just going to add. We're going to add 55 plus 115. We get 170. And we know an entire circle is always 360, so we're going to minus that 170. And we get 190 degrees. So this is 109. Now you check. Have you found all the arcs? We only have 3 of them. 1, 2, 3. Good, we're done. Now I'd like you to frame the angle LMK. Frame LMK. Trace first. Trace LMK. Trace and sweep. Now get your Post-its and let's frame it. So there's one Post-it here and one Post-it here. Okay, you should notice, remember an inscribed angle is half the arc, so the angle is half of the arc. Half of. So if that's 109, you ask yourself, what is half of 109? What is half of 109? So we just take 109, we're going to divide by 2. Two goes in there 5 times, 10. Excuse me, it's not 109, it's 190. Let's double check that. It's not 109, it's 190. The other way around. No more taping on a Friday afternoon, 190. Okay, so half of 190, excuse me. Half of 190, of course, is going to be 95 degrees. So our angle back here is 95 degrees. Okay. It says, right here, we're going to do this one together. It says you can do it by yourself, but I'd rather do it with you here. You want to trace the given arc and the given angle. So first, let's just trace what we're given. We are given this arc, 142, and we are given this angle, 33. And we're going to frame a bunch of stuff and see what we can do here. So first off, it says to frame LMN. So let's trace LMN. Start at L, go to M, go to N, and frame. Put your Post-its here. There's one. Here's the other. Now the green angle, LMN, is inscribed, so the angle is, let's go this way, it's half of that arc right here, this arc on the outside. So all we have to do there is take that 33, and now we double it. So we take that 33 because it's half of something, and we times by 2. So our arc here is 66. So back here is 33. That is going to be 66. So now we're done with the first one. We can find that. We're supposed to find all possible arcs and angles. So we just found that one, so cross it out. Now we're going to frame MNL. Let me change colors here. MNL. We're going to do that in purple. Let's go M. M. N. L. Trace and sweep. There's that angle back there. Okay? So now frame that one like so. Put your post-its here. And put your post-its here. That angle is half of the arc it's grabbing. It's grabbing out here. So if that's 142, this back here is going to be half of 142. And of course, that's going to be 71. So back here, this is 71 degrees, that angle right there. Now we have in here, notice we have a triangle in here. See the triangle? So now to get that third angle, we don't have to do the inscribed. We can just add up 33. We're going to add 33 and 71. We get 104. We're going to take that away from 180. And we should get here 76. Now the last thing I want you to do, notice we have three angles. We're still missing this arc back here. This arc here, we're missing. So I would like you to frame that 76. Frame. Put your post-its like so. You have one post-it here. Put one post-it here. Frame that up. Now that angle is half of that arc. It's half of. So we ask ourselves, what is half of 76? What is half of 76? So half of what is 76? It goes like that. So you should see all you do is to 76 is we're going to double it. So we take 2 times 76. We get 152. Now, here's how you can check. Here's the last little thing you can always check. We know circles add up to 360. So let's find our arcs. Let's add them up here. We're going to go 142 plus 66 plus 152 equals, you can see you're correct, it's 360. Easy way to check your work is to add up, if you find all the arcs, check them out there and see what happens. Should add up to 360. Make sure you bring those post-its with you to class, please.